Thanks everyone for joining the session today. This is session 2BH in the DV2 stream. Unfortunately, it's the second to last one this year for GSE, and unfortunately also for Marcus, it's the one after lunch. So hopefully, he reckons he can keep us all awake. So I'll take that as a good sign. So we've got Marcus Davidge from BMC, who's doing a session on DevOps versus DBA. I think most of you know Marcus anyway. So without further ado, oh yes, of course, there's a few other points I should point out. Yes, please do contribute to our charities, the RNLI and Guide Dogs for the Blind this year. And if you've got any questions, stick a hand up or put it in the chat and we'll certainly get round to them when we can. Okay, thanks very much everyone, and passing over to Marcus.
Right, thank you very much. So there, Colin said everything. This is not going to be a particularly technical session. I am not going to try and emulate Julian's masterful session this morning, which was a how to do DevOps. My session is more of a why to do DevOps. There's no technical content. There is unfortunately a lot of comedic content. So if I can click on that, let's go. Please donate to the lifeboats and guide dogs. This is not a pipe. In 1929, the famous Belgian surrealist artist René Magritte painted The Treachery of Images, or Cécine Palmpipe. This is not a pipe. He said, perception always intercedes between reality and ourselves. So to prevent me from going down the path of exploring the philosophy of abstraction and its implementation in the fundamentals of computer science, let me tell you why I mentioned these in the first place. Pipes were ubiquitous then, as smartphones are today. So let's consider a smartphone. This is not a phone. It's not even a picture of a phone. It's a picture of something that represents more than just a phone. Yes, it's a communications device, but it's also a calendar, a diary, a calculator, a computer, a web browser, a music and video player, a camera and a gallery, a note taker, a reminder, a clock, an alarm, a branch of your favorite grocery store, your bank branch, a GPS location tracker, a sleep tracker, a fitness tracker. With it, we can access any piece of information from the sum of all acquired human knowledge in an instant. We can communicate face-to-face with anyone in the world instantly. Yet we use it to argue with total strangers on the internet and post pictures of lolcats. We're all consumers. Software updates pander to our insatiable demands for instant upgrades. Amazon, Netflix, Facebook, Google, Apple, they all push software upgrades to our phones at a faster and faster rates. We expect there to be improvements and new features with each update. We expect no bugs. We expect smooth transitions. Users are demanding more and better releases of newer and shinier features to their favorite applications. What makes our customers any different? We live in an instant society. We want instant gratification, instant coffee, instant family, instant noodles, instant mom, instant Haltungsmanagement, whatever that is, instant crush, instant Legolas. I mean, really. We live in an instant society. It seems that the words of Freddie Mercury expresses the zeitgeist, I want it all, and I want it now. Enter DevOps. DevOps is a portmanteau. No, not a large leather suitcase that opens into two hinged compartments, but a word that is created when the sounds and meanings of two different words are blended into one. First observed in Belgium, 80 years after Magritte's Not a Pipe, DevOps aims to combine software development and IT operations, shortening development life cycles by providing continuous delivery and continuous integration with high software quality. Complementing the agile methodology, like siblings in the same family, DevOps aims to deliver software better, faster, safer, cheaper, and happier than previous efforts. It breaks down the barriers that define the silo mentality that plagued software development for decades. DevOps is not only adequate information, sufficient scheduling, and tolerable tooling, it's about a culture of communication, of people, practice, and process. DevOps is not just a word, it's a world that's created when the sounds and meanings of two different worlds are blended into one. But is everything in the DevOps garden quite as rosy as the idea suggests? Here is where perception and reality can clash. Update your app? Certainly. Download, install, replace. Update your operating system? No problem. Shift your workload, bring down your LPAR, upgrade, bring it up again, move on to the next one. You want a database change? Sure. Unload, drop, recreate, reload. Oh, sorry, you didn't say that you didn't want an outage. Now, every DBA knows you don't replace an entire database or even a table for every schema change. DB2 has become far more capable of handling online schema alters and changes and alters with deferred share level change reorgs. There is always that little outage though, isn't there? The dreaded switch phase. The tools that are now available to developers enable them to perform more and more software changes more and more frequently. We call this the release velocity. Database schema changes, however, do not traditionally take the same path. The database release velocity is generally slower, far slower. It takes seconds, even minutes, even hours to deploy. Sorry, start again. It takes seconds to deploy a new copy of code, but it can take hours or even days to drop, recreate, and reload a multi-terabyte table space. The deployment gap or velocity gap is this difference. So let's consider for a moment the difference between traditional waterfall development and agile. With waterfall, no real value is delivered to end users until the very end of the project, when code is moved to production. With agile, development teams can deliver improvements in smaller chunks more frequently, instead of waiting until the end of a project. Value is added incrementally over time, and beginning very early in the project lifecycle, instead of waiting until the end of what may be a monolithic project. And when the development processes are properly automated, as encouraged with DevOps, the result can be less risky, even when teams are putting out releases more often. You will hear the term shift left when discussing DevOps. What is that? Well, the traditional software development lifecycle progresses through many stages, usually shown on a diagram from left to right. We start by gathering requirements, move on to designing the application, then developing and writing the code. After that, we test it thoroughly and only then deploy the application to production. DevOps brings a shift left mentality to the software delivery lifecycle. That means that processes on the right are moved to the left, so they are performed earlier in the development lifecycle. You may have heard of test-driven development. This is it. Developers have a well-defined automated process or pipeline to deploy code from system to system. However, when there is a schema change involved, the process has to stop. It becomes a manual process of contacting the DBA, maybe through a remedy or ticket system. And then the DBA having to find time to determine what the developer is doing, what has changed, will it impact my system, does it follow our naming standards? The development process is on hold. So why is the DBA a bottleneck? The developer is happily coding away, making changes to his applications according to business requirements. Oh, he needs a new column added to a table. He asks the DBA who makes the change. And another change from another developer. And another change from another developer. Eventually, he deploys the change to prod. Ops sends a prod reorg request back to the DBA. Do I have time to deploy it? What about everyone else's changes I have to import, analyze, validate against performance metrics, verify against site standards, and execute, and all of the production changes? I have to keep the system running. Plus, I was called out for 4 hours last night. Now you can see why the DBA is a bottleneck. Over the years, the role of the DBA has included High Priest of ZOS, Scribe of the Sacred Site Standards, Gatekeeper to Production, Management Piñata, Superhero, Supervillain, and SQL Guru. Now in these strange days of Agile and DevOps, the role of the DBA is to change once again. How did we get into this mess? Why is the database administrator such a bottleneck? Why do we even need them? To understand, we need a little history lesson. In 1981, Doug Leonard developed an artificial intelligence program called Eurisco. It outwitted the best US Navy chiefs in a highly complex strategic war game called Traveller. It's a well-known saying that a navy only moves as fast as its slowest ship. Eurisco quickly learned this behavior and sank its own slowest ships and quickly defeated all of its opponents. So how do we close this velocity gap without shooting all of our DBAs? Let's have a brief history of DB2. Computerized databases started in the 1960s. There were two popular data models in this decade, a network model called Codicil and a hierarchical model called IMS. In the 1970s, E.F. Codd proposed the use of a relational database model, in that the database's logical organization is disconnected from physical information storage, and this became the standard principle for database systems. A new database model called Entity Relationship, or ER, was later proposed by Pete Chen. This model made it possible for designers to focus on data application instead of logical table structure. Two major relational database systems prototypes were created between the years 1974 and 1975. They were the Ingress, which was developed at UBC, and System R, created at IBM San Jose. Ingress used the query language known as Quell, and it led to the creation of systems such as Ingress and Sybase. On the other hand, System R used the SQL query language, and it contributed to the development of SQLDS, DB2, Oracle, and Nonstop SQL. It was also in this decade that Relational Database Management Systems, or RDBMS, became a recognized term. 1980s. Structured query language, or SQL, became the standard query language. Relational database systems became a commercial success. DB2, announced in 1983, became the flagship database product for IBM. And the introduction of the IBM PC resulted in the establishments of many new database companies and the development of products such as Paradox, DBase 3, and DBase 4, and of course the OS2 database manager. DB2 2.2 in 1988 improved performance and introduced distributed database support. 1990s. Prototypes for Object Database Management Systems, or ODBMS, were created in the early 90s. DB2 2.3 was announced in 1990, bringing in packages and segmented table spaces. In 1993, version 3 brought in compression and parallelism. Version 4 brought in data sharing, stored procedures, and type 2 indexes. In 97, version 5 brought sysplex parallelism, statement caching, and online reorgs. 1999 saw version 6 and LOBs and UDFs and UDTs. 2000s. The three leading database companies in the Western world are Microsoft, IBM, and Oracle. DB2 version 7 brought scrollable cursors. DB2.8 delivered more lines of code than V1 had total lines of code, and DB2.9 dropped the V. A weird bunch of dogmatic computer scientists got together to develop a manifesto for agile software development. I mean, who even writes manifestos? Communist dictators or people with a point to prove? Well, this was groundbreaking, cutting-edge stuff that turned user requirements into user stories and aligned those to development tasks, and completely changed the face of software development from now on. The 2010s. Versions 10, 11, and 12 of DB2 bring us up to the present day, with online schema change and online utilities, making database change-related outages a thing of the past. It brought continuous delivery, blazingly fast inserts, encryption, RESTful services, and most importantly, and above all else, a lowercase b. Also, DevOps is born. So let's go back to the DBAs and how they fit in the DevOps agile world. Here is an agile DevOps developer delivering database changes to the DBAs. And here is a DBA being invited to an agile scrum. Not really, this is a joke. DBAs are never invited to agile scrums. We need to talk about the DBA. We still need the DBA, but their expertise and role need to be integrated into the DevOps process. DBA designs, plans, models, changes, implements, supports, and maintains the database lifecycle from development through to various testing environments and into production. Your organization may still have separate development DBAs and production DBAs, but they still need to coordinate. In DevOps, developers, including development DBAs, and operations, including production DBAs, need to work together to deliver changes at a pace that satisfies both operational availability and development targets. Don't just invite DBAs to your scrums only when you need them to implement an emergency change to a development environment because they haven't got the authority to do it themselves and have thus stalled, calling DBAs blockers. DBAs need to be involved from the very beginning of the project design from Scrum 0. DBAs, don't just provide databases and configure them. They provide backups, recoveries, reorgs. They design database. They are SQL experts. They are performance experts. They manage schema changes. They make sure they adhere to site standards. They make sure that your SQL is of good quality. Oops. Yeah. Databases are not the same as apps. They need to be made, database changes need to be made before code changes. Database changes have a higher risk because of the involvement of user data. They're potentially intrusive. Sometimes you need an unload, drop, create, load. Sometimes there's environment drift. When I was a DBA, there was one particular application where we had 21 environments, each with their own parallel development and one production environment. Somebody had to keep track of all of the changes. We were involved in making sure all of the tables and databases had backups and recoveries, testing recoveries. We made sure tools were available, particularly integrating into change management. DBAs were the ones who knew the dependencies with other systems. So when a developer came along and said, I need to change this table, the DBA would say, no, you can't. This is used by someone else. Thankfully, IBM has enabled more and more DBA tasks to be performed with pending alters and online reorgs, thus making the DBA's job easier and the ability to introduce new application functionality more easily with less service impact. So what's stopping you from adopting DevOps to databases? Bad attitudes, hero complex, custodian mindset, you shall not pass, data sentinels, or control freakery? We've always done it this way. Well, so what? What are other things that we did that we don't do anymore, like leeches, asbestos, and smoking? What else shouldn't we do anymore? Old-fashioned manual change control procedures, tickets or change requests to change the schema, 3-week lead times, manual changes. DevOps is about people, processes, and tooling. We need a culture change to be able to move at a speed that our customers have begun to expect from us. The culture change extends down to the database level. We need to involve the DBA from the beginning, from the very beginning of the agile development process. We need to trust developers to make their own changes as and when they need. We need to define done as production, not just test. Support must be provided by the DBA every step of the way. Get rid of tickets for DB changes. Enable the developers to do it themselves. Provide automation and orchestration tools to make life easier, and rely on development to keep good standards. Leave it better than you found it. The DBAs have got a lot of knowledge, and they can pass that on to the developers to help them look after their own environments. If we enforce automatically naming standards and physical design standards and SQL performance standards, then the DBAs can sit back and rest, knowing that nothing will pass that hasn't been validated. And teamwork makes the dream work. Collaborate, cooperate, and communicate, and invite DBAs to agile scrums. So in order to achieve this brave new world, we need to treat our database changes as code. As Julian said this morning, there are two ways of making database changes, excuse me, state-based or migration-based. So a state-based, you have source control, system of record, you establish a snapshot of the database. The DDL of your schema is stored as a controlled source control text file. You use a compare engine, you compare against a target, and the engine optimizes the change for the target. So only that change gets applied. Migration-based is more of a database system of record. You capture the state at the beginning of the project, and you maintain a series of sequenced steps, and you use a culmination of scripts to achieve the desired state. Using methods like this, all changes are scripted and automated, all backouts are scripted and automated and tested. All changes are under source management version control. You have the ability to release or to back out on demand. And the DBAs are integrated with developers and operations. You can have inbuilt automatic validation of both DML and DDL. Automate all the things. Table changes. You can encapsulate and automate if you treat your database changes as code snippets. You can apply changes, you can apply schema standards to your DDL. Does my index look right? Does my table space and index space have the same stow group as my database? Things like that. Basically, the DBAs know the standards. They encode the standards in rules, and the rules are applied to the DDL during the pipeline. The pipeline stops on failure. You can automate SQL assurance or performance metrics. You can police your performance. Are you doing a table space scan? Are you doing a select asterisk? Are you doing a non-matching index scan? Are you doing an index scan, but you've forgotten the first column? Once again, the DBAs encode the rules are applied, and the pipeline stops on failure. Backouts and recovery can all be automated. Automate all the things and embed it in the pipeline. The DBAs maintain control of the process and the rules and can override it if necessary. For example, you've got a batch job that runs once a year and it validly does a table space scan of 1 million pages. You wouldn't want that to run in an online transaction processing environment, but you need to make sure that it does run once a year in a batch job. The SQL performance metrics would stop that from going up the pipeline because it's a table space scan of more than 1 million pages, but the DBA can override it because he knows that it's only run once a year in a batch job. So having automated everything, the DBAs maintain control. The developers are free to deploy at a pace that's that they are happy with. And operations are happy that prod is safe because everything's automated and validated. So, DBAs. By letting developers themselves move their own database changes around, are we handing over the keys to the kingdom? The DBAs relinquishing the control they have so jealously guarded for generations? No. With the right tools, early involvement in the development process, and robust change impact assessments, the DBAs still get to keep the keys. They are merely handing over automatically enforced locked standards and orchestration methods that enable developers to get more done themselves and to do so safely. By defining site standards and SQL performance rules and embedding them in the orchestration tools and automated migration processes, the pipeline, they are keeping the keys, just handing out locks. In the world I'm suggesting, database changes are thoroughly impact assessed, and schema changes and the schema change management tools encapsulated in the change orchestration process. DDL is automatically validated against site standards that the DBAs have set, and the code's SQL statements are analyzed and compared against performance rules defined by the DBA, making sure that production SQL performance does not degrade. So a developer can migrate their own changes through any environment up to, but obviously not including production. The DBA approves production changes, solves any issues or major impacts along the way. For example, BMC's AMI DevOps for DB2, along with SQL Assurance and Schema Standards, provides this functionality. IBM and Broadcom also provide tools that do the same. Sounds great, doesn't it? Perception always intercedes between reality and ourselves. This may well be true, but if we change our perception of who does what and when, we can create a new and more effective reality. This is not a phone. This is not a pipe. It's a pipeline. And this is not a DBA. It's a DevOps DBA. Thank you very much. Please submit your session feedback. The session is 2BH. If you're not a member of GSE UK, these are the benefits that are available. I'm out.
Right. Thanks very much, Marcus. We've got one question from Paul. He says, how do you change that change? How do you think that change management approval fits into DevOps requesting schema changes being pushed into environments such as UAT and production?
Let me read that. How do you think that change management approval fits into DevOps requesting schema changes being pushed into environments? Well, yeah, this is a culture change. So you have to work out your own ways of integrating DevOps into your change management process. I would say that there would have to be conversations between DevOps, the developers, and the change management team. Automation to UAT as much as possible. As soon as you hit UAT, you can get approvals, and definitely before production, you need approvals. So it's up to you. You need to be able to fit it in where you think your change management needs to be. But it's definitely conversations between the DevOps teams and the change management. There you go. Any other questions?
Is that okay, Paul? Or have you got any further questions on that? Put your hand up if you want me to unmute you. Anybody? I've got a question in the chat. Nothing coming through at the moment.
Hope you don't.
Right. Well, thanks very much for that, Marcus. That was great. That was a great laugh and certainly kept everybody awake for sure. And thanks for taking the time, because I know it's quite a rush to get all this ready for 2 o'clock today. I think more of a rush than you expected.
Yeah, a bit.
And that's why the files aren't quite ready just yet, but they will be up there when we can load them up. Okay, thanks everyone. There's one more session for DB2 today, and that is at 3:30. We've got Chris Crone with updates on DB2 continuous delivery. Until then, I think it's a kind of a coffee break and catch up, and we'll see you then. So thanks very much everyone for attending, and we'll catch you later.
Bye.